Okay, so we are continuing our discussion in this video on arithmetic sequences. So just as a quick review of where we've been, we talked about just series and sequences in general, what they are, how to make them. In the last video, we talked about the 4 different kinds that we're going to study in our class. And now in this video, we're going to talk specifically about one of those types, or maybe a pair of those types, arithmetic sequences. It doesn't matter if it's finite or infinite. Same thing applies to what we're going to do in this video. For an arithmetic sequence, how do you find its formula? How do you generate its formula? So that's what this video is going to be all about. All right, so quick look at the learning objectives. We already should, from the last video, know how to recognize an arithmetic sequence, but that's going to be a key skill in writing its formula. So you have to know that it's arithmetic before you can find its formula. All right, so in the last video, we talked about the 4 different types. Whether it's a finite arithmetic or an infinite arithmetic, that's what we're going to focus on in this video. But we did talk about finite geometric and infinite geometric. We'll talk about that in the next video. All right, so here we go. Let's do an example like, well, let's work through the concept of this together first, and then we'll do an example, okay? So, all right, so here's a sequence for you. Let's say that we go 6, and then 12, and then 18, and we're going to continue this pattern until we get to 66 and 72, and then we're going to stop. Okay, now we have not seen a lot in our class, or in the videos at least, a problem where the ... is in the middle. I think we've looked at that once or twice, but we haven't seen a lot of that. ... in the middle. Remember the ... what it literally means is that there is a pattern that continues to happen. When we put the ... at the end, that tells us that it continues forever, that the pattern will continue forever. But here, when we put it in the middle, that means the pattern that we see with these will continue until we get to this. And then in this case, it stops. All right, so let's start with a review. Pause the video real quick and think about what kind of sequence is that? Of our 4 different types that we looked at in the last video, which kind is this? All right, so you should recognize that this does indeed stop. That makes it finite. You should also recognize that my pattern is that I'm adding 6. And that pattern seems to be consistent. So once I see that it stops, and I see the pattern is adding 6, this is a finite arithmetic sequence. Okay, so that's what it is. So that's what we've got from the last video. All right, but now, what we're going to talk about in this video is the fact that it's arithmetic. That's what we're going to talk about, that is how do we find the formula for an arithmetic sequence? And to help us, here's what I want you to realize. Notice, as we said before, that due to the fact that it's a sequence, that means these numbers have been arranged in a specific order. This is the first number. This is the second number. This is the third number. Now there's some ... so I'm not sure which number this is. You know, maybe it's the 5th number, maybe it's the 100th number, maybe it's somewhere in between. At this point, I'm not 100% sure. I probably could do some figuring to try and get that to deduce where it goes, but I'm not sure right now. Okay, so maybe for right now, I just call this the question mark number. Okay, I'm not sure. But with an arithmetic sequence, because they go in a particular order, what we talked about is that this gets called a sub 1. And that means that when we worked with the formula, we plugged a 1 into the formula to get 6. And this is called a sub 2, meaning that we plugged a 2 into the formula to get 12. And this one, a sub 3, and so on and so forth. Okay. And one of the things we talked about is that makes the formula work sort of like a function for a minute. So let's pretend for just a second let's pretend for just a second that this is a function. Let's pretend for just a second that this is a function. Okay, so what would that mean? That would mean if these are the numbers that I'm plugging in, that would mean these are my x numbers. So I'd have x numbers of 1, 2, and 3. And then if these are the answers that I'm getting, those are my y values. And remember, y is the same as your function, right? F of x, whatever you want to call it. Okay, so those are my y values. So when I look at a sequence, it's almost like they've given me a table, but they've only showed me, I'm not sure what this one is or this one, they've only showed me just the y values. They haven't showed me the whole table. And I have to recognize there's an assumed set of x values, okay? The fact that this is first, this is second, this is third, assumes that my x values are 1, 2, and 3, okay? Now, if it was a function, I also could make a graph. So let's think about this for a second. If I made a graph, I'm going to count a little funny on this. I'm going to count by ones on this axis. So 1, 2, 3, 4, 5, so on and so forth. And on this axis, I'm going to count by sixes because my pattern is 6. All right, so my graph is going to look a little distorted because I've changed one of my axes, but not the other. But that's okay. We'll be all right. Okay, so I'm counting by sixes on that axis. All right, so what have I got? My first point is at 1, 6. My second point is at 2, 12. My third point, 3, 18. Now, they didn't give me what happens in the dot, 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 but I know the pattern is to add 6. I know that's my pattern. And since my pattern is to add 6, I can extrapolate out. If I add 6 to 18, I'm going to end up with my fourth point being at 24. And if I add 6 to 24, I'm going to end up with my fifth point being at 30, and so on and so forth. Here's what I want you to notice. When I graph an arithmetic sequence, if I pretend that it's a function, and I assign some x values to it, and I draw a graph, the graph that I end up with is a straight line. The graph that I end up with is a straight line, okay? So what that means to me is that arithmetic sequences act very similar to linear functions, all right? And that is going to be the key for how we find the formula. Arithmetic sequences act like linear functions. Now, we haven't studied linear functions since last semester, so you might be a little bit rusty on linear functions, but you also studied them quite a bit in your last algebra class. So hopefully there are some ideas that you remember. Like, for example, when we're working with linear functions, we tend to write the equation y equals mx plus b. Okay, now think about what that means. In function notation, y is the same as f of x. So this would be our equation notation. In function notation, y is the same as f of x. M is the slope, right? So that's going to still be m. X is what we're plugging in. That's still x. What was b? B was the y-intercept. And the y-intercept happens when you plug in 0 for x, right? That's something we've learned about every single function. Always, the y-intercept is what you get when you plug in 0 for x. So if we use function notation, the y-intercept would be f of 0. That would be function notation. Okay, but now let's take this into sequence notation. If it's sequence notation, we're not going to use f of x, we're not going to use y, we're going to use a sub n. We still need to know how things changed, but this tweaks just a little bit. When we were talking about graphs equations and functions, m represented slope, and slope we knew was rise over run, okay? But now here's what we've got. Our run is, in an arithmetic sequence, the run is always 1, right? We're always 1 because we're just assuming that this is first, second, third. And because we make that assumption, that means my run is always 1, always. So if my run is always 1, we do change what we call it. We don't call it slope because it's not rise over run. We call it the rate of change. Okay, how fast does y change when x changes by 1? Or more correctly, how much does the term change when I go to the next term? So we call that rate of change, and we use an r. Okay, so the m is slope, but that's the same as rate of change. Okay, so we use an r instead of an m, but they mean the same thing. Now we're not plugging in x's, now we're plugging in n's. So we're going to have the slope, I mean the rate of change times n. And then we're going to add what we get when we plug in 0. But in sequence notation, that looks like a sub 0, a sub 0. And so this is the formula that we will use to find an arithmetic sequence. Or this is the structure that we'll use to find the formula of an arithmetic sequence. All right? So that bottom line is what we need to recognize from this video. This is our main takeaway. The formula for an arithmetic sequence will have the structure. A sub n equals Rn plus a sub 0, okay? And we know that this is the value of the term. So is the term 6 or 12 or 18 or whatever. This is the rate of change, okay? This is the number of the term that you're studying. Is it the first term, the second term, third term, whichever? Can't spell number, sorry about that. Okay. And then last but not least then, this would be the 0th term, okay? This is the 0th term. Okay, term number 0, which is what you get when you plug in 0. Now, you might be thinking for a second, wait a minute. If I have a sequence, there is no 0th term. The thing that comes first is the first term. There's nothing that comes before it. There is no 0th term. And you're 100% right. So the 0th term is what you get when you plug in 0. It's not actually like you can go look at the sequence and find the 0th term. You won't find it. It's not there. It's kind of like an imaginary term. I don't want to use that word or that phrase because that might make it feel like it's supposed to be an imaginary number or something, and it's not, okay? But it is something that you're not going to see on the paper. You're going to have to figure it out every time. So with all of this done, let's see if we can go ahead. Oh, I am going to add one more little statement right here in just a minute. But before I add that statement, I want to look at the sequence that we just considered and see if we can find its formula. So now let's find the formula. Find the formula of our sequence. 6, 12, 18, ... 66, 72. Okay, let's do that. Find the formula of that sequence. All right, so one thing that I'm going to need to know is rate of change. Ooh, I said rate of term. What is that all about? Rate of change. Make sure you've got the right name right there. I know I said rate of change when I wrote it, but I wrote rate of term. Okay, rate of change. Make sure you've got the right thing in your notes. Rate of change. All right, so rate of change, we said The rate of change is how much the value goes up when you move one spot. Okay, so if we looked at this graph here, how much did the value move up when you went over one spot? Okay, so what we end up with is that my run will equal 1. Okay, my rise is going to be equal to whatever the pattern was. How much are we adding on? Okay, so in this case, we added on 6, and I went over 1. And because it's the same idea as slope, then that can be the way that I find it. In this case, adding 6 over 1, that just equals 6. Okay. Now, it can be a little bit more complicated than that, and we'll see that in our second example. But basically, what we're finding when we find the rate of change, I told you I was going to add something right here, is we're finding the pattern. That's what we're finding. What is the pattern? Because you're going to end up with the pattern divided by 1. And if the pattern is divided by 1, then there you go. Okay. So I have a pattern of adding 6. So that means my rate of change, I'm going to just put ROC for rate of change, if that's okay. My rate of change is add 6 plus 6. Okay, so which we call, I'm not sure why I put ROC. The rate of change is clearly called R. Okay, clearly that's called R. Okay, so if I start writing my formula here, I'm going to have A sub n. Just like when we write the equation of a line, we always just write a y because it's got to represent all of the y values. Here we write a sub n because it's got to represent all of the term values. Okay, so a sub n equals, and now plus 6, that's my r. Okay, I leave it as an n because I have to have a spot to plug in the number for the term I'm looking for. So it's got to represent any term, so we just leave it as an n. And now we've got to find a sub 0. So to find a sub 0, we have to pretend for a second, what if there was a term that came before a sub 1? If this is a sub 1, then the term that came before it would be a sub 0. Now that term's not there, but we need to figure out what is it. And so we know, because we've done this before, if my pattern is adding 6 moving this way, if that's my pattern, then to figure out what goes right here, I'm going to go the other way, so I'm going to subtract 6. So 6 minus 6 is 0. So I'm going to have a plus 0. And then we just finish by simplifying. So a sub n equals 6n. And there is our formula. Okay, so that should feel very much like what we did back when we were learning how to find the equations of lines. All right, so that's the main idea. I am going to do one more example that's a little bit more involved, a little more complicated, but it's the same basic idea as this. So if you remember a lot about finding the equations of lines and you feel like you've got this, you might pause the video now and start doing your homework. But if not, let's finish out with one last example. All right, example number 2. So find the formula of the arithmetic sequence. Now, the fact that it's arithmetic is going to be important on this problem. On the last problem, they didn't tell us it was arithmetic. So we had to recognize the pattern and that it was adding 6 so that we could figure out the answer. But this problem, they're telling us that it's an arithmetic sequence. That's going to be important because they're only going to give us a couple of points. The arithmetic sequence where a sub 2 is equal to 6 and a sub 4 is equal to 16. Okay, so they've given us considerably less information, but we still need to know the same 2 things. What is the pattern when we move from one term to the next? And what is the 0th term? We still need to know those same basic things. Rate of change, the pattern from one term to the next, and the 0th term. Okay. Now, if you feel like you've got an idea on this, maybe pause the video and try it. All right. Whether you tried it or not, you need to recognize that I have a scenario where there's my first term, there's my second term, there's my third term, there's my fourth term. And I don't know for sure if this goes on forever or not. It didn't tell me that it doesn't, so I'm just going to assume that it does. It doesn't really matter for the purposes of this video. And what they told us was they told us this one, and they told us this one. Okay? So you need to go through some sort of logical process to figure out what is the pattern. What is the pattern? And notice that what we have done is we've gone up 2 spots. And we know, because it's arithmetic, that when we went up 2 spots, we either added a number or subtracted a number, and it was the same number both times. In this case, because I'm going from 6 to 16, I must be adding a number. So I added something, and I did that twice. So the first challenge that we have to figure out the rate of change is we need to know what was the number that I added. Okay, so here's the way that I approach that. I can very easily figure out the total change to go from 6 to 16. I just subtract, right? That gives me my total change, 6 to 16. So in this case, that's 10. But I know that the actual rate of change happened in 2 steps. So if I take the total change and I divide that by the number of steps, then that should tell me how big each individual step was. So in this case, there were 2 steps. So if I divide my total change by the number of steps that I took, that should give me my rate of change. Okay, now this basically becomes a formula that you can use. Total change divided by number of steps is rate of change. It's a very similar formula to rise over run. Okay, very similar formula to rise over run, because rate of change is basically the same as slope. So this can be one way that you can do it. So now I know that my rate of change is 5. So I can start filling in the pieces that I need. Like, for example, I can fill this piece in if I want to. 6 plus 5 equals 11. 11 plus 5 equals 16. That allows me to check to make sure I got the right answer. And it looks like I did. But what I actually need is this back here, my imaginary 0th term. So you can do this 2 ways. One way that you can do it is to subtract off your rate of change. Okay. Now in this case, because we're only 2 spots away, that would be perfectly fine to do. So if I subtract off 6 minus 5, that's going to give me a 1. And subtract off again 1 minus 5, that's going to give me a -4. So now I know that it's -4. And that's a fine way to do it when you're close. But imagine for just a second, what if this wasn't term 2? What if this was like term 200? I'm not going to want to subtract it off 200 times. So what you could do instead is, again, use a formula based on knowing the total number of changes, or the total, the total distance that we're going. And it basically becomes this same formula where we put in something that we're not sure about. So if I know that my rate of change is the total change over the number of steps, so the total change is going to be where you end up minus where you start over the number of steps. Well, what we don't know is we don't know where we started. So if I rearrange this equation, in other words, if I solve for where you started, then that'll tell me a formula to get a sub 0. So let's think about what this is. I'm going to multiply both sides by the number of steps. So the number of steps times r. Okay. Now I can subtract the end from both sides. Whoops, start. And then last but not least, I'm going to have to get rid of that negative sign. So when I get rid of the negative sign, I'm going to end up with the opposite of steps times r plus the end equals the start. All right, now that's really complicated. Let's put this in more simple terms. The number of steps is simply the number of term that you're on, right? To go 2 steps, this was a 2. So the number of steps, that's going to be equal to n. R, obviously, is equal to r. And then end, that was the value of the term that we knew. So that was a sub n. Okay? So there are our 3 pieces that let us find a sub 0. So if you want a formula for finding a sub 0, a sub 0 will be one of the terms that you know. Whoops, sorry, you can't see that. One of the terms that you know. So in this case, we knew the second term. Times r. You know what? I'm going to actually write this in a different order. That just looks nicer. Not because it's mathematically better. It just looks nicer. I'm going to put the positive thing first. So the value of a sub n, that we know. And then we're going to have minus r times the number of the term that we're on. Okay, r times the number of the term that we're on. Okay, and now in this case, notice that we're going to get the same answer. So we already calculated by just subtracting twice, that's equal to -4. But if I plug in the 2 and the 6, a sub 0 equals the value of the term minus the rate of change, which was adding 5, we said, times the term. Okay, so adding 5, I don't really need that plus sign, right? We can know that it's a positive just simply because of the fact that I didn't put a negative sign. We know it's positive. So I do 5 times 2, that's 10. 6 minus 10 is -4. And there's my a sub 0. And that matches what I calculated right here. Okay, so with this example, I've shown you basically 2 techniques. One technique, if the numbers are close together, you can probably just reason it out. And there's nothing wrong with that. Feel free to just say, well, if I went up 10 total, then this must be 5 and this must be 5. That's okay. And if I know I'm going up 5, then if I just subtract off 5, then that must be where I ended up with here. It's okay to just reason it out. That's okay. But if the numbers are big, if you've got step 200 and step 400, it's going to be hard to just reason it out like that. So this is where our formulas can be helpful. So my function right here, there's my formula for figuring out the value of r. And then there's my formula for figuring out the value of a sub 0. Okay, both of those will work for you. There's nothing wrong with using either one of them. They're both just fine. All right, so that is it for this video. Thanks for watching. Have a good one.